We really don't have time to wait. Okay, so we know that a square matrix means that we have a matrix with the same number of rows as columns. So if we do have a square matrix, we can find the inverse, which is what we did yesterday. And then today we're going to be finding what's called its determinant. So it says if a matrix is square, then we can assign to it a number called its determinant. So each square matrix has a determinant, just one number that can be assigned to it. And then this can be used to solve systems of linear equations, and we'll see that later. Systems. Oh, it is? Okay. All right. So we can use the determinant later for a couple different things, which you'll see. So first of all, and it can also help us determine if a matrix actually has an inverse. Because remember yesterday we saw that if we were in the middle of solving and getting the left side of the equation to a reduced row echelon form, the identity matrix, and it can't, then we know it doesn't have an inverse. So there's a quicker way to determine if some matrix doesn't have an inverse, and that would be with the determinant. So we'll see how to use this, but first of all we got to get used to some notation. So if we start with this matrix A, some matrix A, it looks like this with these brackets. We know that that's what creates a matrix with elements A, B, C, and D. How you're going to see it ask you to give the determinant is a couple different ways. They could say the determinant of A, find the determinant of A. Or they'll usually actually just put it in these, like, it looks like absolute values, but it's not. In matrix, this symbol of straight lines means find the determinant. So they might not even say find the determinant. They might just put the matrix in straight lines, like this. And that goes without being said when you see the straight lines, that means find the determinant. So this is actually the determinant, you guys. A times D minus B times C, which we've seen that formula before. Last time, do you remember that that was what was under the fraction? Okay, so in our inverse equation for this, our inverse equation was this: 1 over A times D minus B times C, parentheses, we switched D and A, and then B and C had opposite signs. So we remembered that if we get a denominator of 0 here, we would not have an inverse. So therefore, can't we say, since this is the determinant, look, this is the determinant, what's on the bottom of the fraction, if our determinant equals 0, we know it won't have an inverse. Okay. All right, so right here, let's go ahead and find the determinant here. So this is how we'd write it. We'd say, okay, we're finding the determinant. So we do our straight line, 6, 1, negative 3, 2, and then we would find our determinant. So that would be 6 times 2, which is 12, right, everyone? Minus, so it's the diagonals, minus negative 3 times 1, so minus negative 3. So that would be 15. So does this matrix have an inverse? Yes, right? Because the determinant is not 0. Now, finding that, so guys, think about this. Okay, that was how you find the determinant of a 2 by 2 matrix. So with that being the case, if it's not a 2 by 2 matrix, we'll have to do a little bit more involved. But it does involve this same type of thing over and over again. You'll see what I mean. So finding a determinant for a 2 by 2 matrix, pretty straightforward. Okay, so let's do it again. Find the determinant of this. So you would say, okay, if I'm asked to find the determinant, 0, negative 1, 2, 3, we would do this diagonal times this diagonal. Sorry, no, this diagonal multiplied, so that'd be 0 times 3, minus negative 1 times 2. So that'd be minus negative 2. So don't we get 0 plus 2? So our determinant calculates to be positive 2. So then we know for a fact this does have an inverse. Okay, so now we're going to see that, so finding a determinant for a 2 by 2 is super straightforward, super easy. It is a little bit harder. It just takes a little bit more thinking, and the steps are a little different for finding the determinant of all other square matrix. So first of all, we need to understand some vocabulary. So this is what you need to pay very close attention to here. Is here I have a matrix, right? Here's my matrix. And is the determinant that's obtained by deleting a row and a column. So it's basically like a minor, you're creating a minor, we're going to delete a row and column, and that's going to create a minor matrix basically. So for example, right here, I'm going to go to, see this says M sub 1, 1, so this M stands for minor. Now this is row and column, so this is minor row 1, column 1. So what that means is, we're going to go and delete column 1 and row 1. So I'm going to go over here, I'm going to highlight what we're deleting. So we're deleting row 1 and we're deleting column 1. So if we delete the highlighted portion, do you guys see how that leaves us with this minor little 2 by 2 matrix? Good point. Now what we can do is we can find the determinant of this minor matrix here. So if I wanted to find the determinant, now we know it's 2 times 6, which is 12, right? Minus 5 times 4, which is 20. So then we would get negative 8. That would be the determinant of our minor matrix. Let's do it again. So right here this says find the minor of 1 sub 2. So that means delete column, row and column first. So row 1, but now we're deleting column 2. So I'm going to go highlight column 2. So what minor matrix are we left with here? 0, negative 2, 4, and 6. Because the highlighted portion is being deleted. Does everybody see it? Okay, cool. So if I asked you to find the determinant of the minor arc here, you would do 0 times 6, which is 0, minus 4 times 2, which is negative 8. So we would get out positive 8. I think we're probably getting the picture here. So look, let's do M sub 3, 3. So that means third row, third column is what's being deleted. So I'm going to go to my third row, and I'm deleting my third column. So then the minor matrix would be 2, 3, 0, 2. So then from there I could find the determinant. 4 minus 0. So our determinant would be 4. Okay, pretty straightforward for the most part. Now what a cofactor is. So everybody write this down. Cofactor, we use this formula basically. So what we do here, I'm going to leave up highlighted the minor arc, the minor matrix of 3, 3 here, where I have it highlighted, that portion deleted. So what a cofactor is it's the constant of the 3, 3. Basically the intersection of what we're deleting. So what part here is the intersection of the deleted row and column? What number? 6. Isn't that the intersection of the deleted row and column? So that would be our constant. So it's the intersection, so our constant would be 6. And then we have to take and we have to plug in, times it by negative 1 to the row plus column. So do you see how 3 plus 3 is what we would be doing here? Row and column? So that would be negative 1 to the 6th power. So what would that calculate? What would the cofactor be of the minor here? So what's a negative raised to an even? Positive, guys. Negative 1 raised to an even degree is positive 1, isn't it? So that would be 6. Okay. So let's go do the cofactor of 1, 1. So once again, if I was to highlight row 1, column 1, where's the intersection happening? At what constant? 2. So 2 would be the number, would be our constant. Then we're going to times that by negative 1 raised to the 1 plus 1, the row plus column. So wouldn't that be squared? So then wouldn't that be a negative to an even degree is positive 1, so we would get out 2. That would be what's considered the cofactor of this minor arc. I keep saying arc because there's minor arcs in that. Minor freaking matrix, not arc. Sorry. Let's go do the cofactor here. So the cofactor of first row, column 2. So the intersection would be 3. That would be our constant. Then we're going to times that to negative 1. 3 sits in the what position? First row, doesn't it? Second column. 1 plus 2 is 3. Isn't a negative 1 raised to an odd degree negative? So this would be a negative 3. So that's how you find the cofactor. So make sure you write down that little formula. Okay. Then, now that we understand what a minor and a cofactor is, we can find the determinant of bigger square matrix. Okay, so here's the thing. I want to make a note here. Note when it comes to cofactors. You don't need to write this entire thing down. I'll tell you what you do want to write down. So note when it comes to cofactors with the sign here. Okay, so look, here would be element first row, first column, wouldn't it? First row, first column. First row, second column. First row, third column. Now in our formula, we know we're adding up the row plus the column. So do you guys see what 1 plus 1 is 2, isn't it? 1 plus 2 is 3. 1 plus 3 is 4. So let's think about that. And then right here would be the second row, first column. So look, I did 2 plus 1, which is 3. 2 plus 2, which is 4. 2 plus 3, which is 5. Then this is our third row, first column. So I did 3 plus 1, which is 4. 3 plus 2, which is 5. And then 3 plus 3, which is 6. Now these are the degrees, right, everybody? These are the degrees of negative 1. So isn't a negative 1 squared negative 1 times negative 1? So won't that always be positive? Think about it. Won't that always be the first row, first column portion? Element. So that would be always positive. Well then right here, if it's 3, isn't a negative 1 to the third power going to be negative? So then this one will be positive. Right here we have negative 1 to the third power. Negative. Positive. Negative. You guys see a pattern here? It's making a checkerboard pattern, isn't it? Our positives and negatives. So that's going to be important to us. So then down here is going to be positive, negative, positive. So basically, guys, you can just think about that. As you go through, if you need to figure out, is it going to be positive or negative, which comes from this part of our formula, you could just think of your checkerboard pattern instead, and that might help you be quicker at it. And it will always start with positive in the top left corner, if you think about it, because 1 sub 1 is 2 always. Does that make sense, everybody? Then after that, it'll just be like checkerboard pattern. Okay, so now we're going to go ahead and find, I'm just going to make sure we're good. If I said to you, find the minor m sub 2, 3, how would you do it? You go to row 2, you highlight, and then column 3. Okay, so then what would be my minor? 1, 0, 3, negative 2. Does everybody see how that is the non-highlighted portion? That would be our minor matrix. And then if I said to you, find the determinant, you could. You do negative 2 minus 0, which is negative 2. Now if I said to you, find the cofactor, what would be our constant? Then we would times by negative 1 to the, where is that sitting? 2, 3, isn't it? 2, 3. So wouldn't that be 5? So won't that be negative 4? Now look, that makes sense. Look, this would have been a positive, a negative, positive, negative, positive, negative. You guys see how that it was negative right here? Okay, cool. Okay, now I can give you the formula to be able to find a determinant of all other square matrix, now that you understand what a minor and cofactor is. Here's the formula. Okay, so all you have to do literally, guys, is it says to define the determinant of a square matrix that is not a 2 by 2, we're going to do, once again, how they'll ask you is they'll say find the determinant of A, or they might just say straight lines A, because straight lines means find the determinant. So right here, if I'm saying find the determinant, all you do is you pick whatever row you want. You can actually pick whatever column you want. It doesn't matter. But whatever, let's say we picked, like in my formula here, I picked row 1. So look, I'm going to highlight row 1. So then from there, you would focus on row 1, and then you would eliminate column by column. So right here, we're doing row 1, column 1 in our formula, and you would find the cofactor times by the minor. So I'm going to do that in yellow. You guys see, that would be yellow. We would find the cofactor and minor of yellow. Does that make sense? Like we just did a second ago. Okay, and you would times them together. Now let's go to, I'm going to go purple. Let's go green, sure. Right here, we're sticking with first row, because I'm just choosing. I randomly chose first row to stay first row. So now we're eliminating second column, first row, second column. So now what you would do is you would write in the cofactor minor of that and times those together. And see, notice they're being added in between. And then right here, I'm sticking with first row, third column. And so now I would, let's change to pink, first row, and then it would be third column. So then we would find the minor and cofactor of that highlighted region, and then we would times them together, and then we just add them up. Now what if you would have, you'll see that you can choose, notice, do you see how I always did first row, first row, first row on all of them? I could have done second row, second row, second row. I could have done third row, third row, third row. So you'll see in a second that it really does not matter which one you choose. So it says note, you can use any row or column, like I was just saying. So I could have also chose a column to always use instead of a row. So you'll see how this works. It's not too bad once you actually see it put into practice. So just make sure you write, oh, I'm going to highlight this. Maybe write that down. Okay, let's put this into practice. That's really going to be what makes sense. Okay, so right here it says, find the determinant by expanding the first row. So this gave us specific instructions. It wants us to do it by the first row, everybody, okay? So what I'm going to do is I'm going to go and I'm going to highlight my first row here. Okay, so now what we're going to do is we're going to eliminate the first column first. So I'm going to just I'm just going to go right here and I need this in the future, this first column in the future. So just keep that in mind. Okay, so right now we're eliminating the first column and we've eliminated the first row. Does everybody see? Okay, so let's go ahead and find the minor and cofactor of that. So what's our minor? Oh, crap. I also notice, let me go back to the formula, sorry. One more thing. Notice what I should have been doing, guys, in all of my formulas, is I should have been putting these, you know how I've been going through and finding the determinant? I should have been putting straight lines instead of brackets. Does that make sense? Because that means find the determinant. So, I didn't think about that. Sorry, this, like I said, this is my first time teaching this, so I'm not thinking of the little things. So, I should have been just putting these all in determinants. Determinant format. So like back to here, go back. Right here, do you guys see what you know how I was finding, once again, the determinant? Oh well, you guys get the picture. Just make sure you put it in straight lines so that you know to find the determinant. Okay, so here we go. Back to it. Here we go. So you'd say, okay, the minor is 2, 4, 5, 6, straight line. Then we're going to times that to our cofactor. Now, times by, what was the cofactor? Where's the intersection happening? 2, and then we're going to be timesing that by -1 to the second, right? 1 plus 1 is 2. All right, let's go on to the next piece here. Let's just write them all in. So I'm going to go ahead and erase this now. We are doing first row, so we're sticking with the first row here. Now we're going to be doing second column. We've eliminated first. Now we're going to eliminate the second instead. So eliminating this. So then plus straight line, what would be our minor? 0, 4, -2, 6. Then we're timesing that to what constant? 3. Isn't that the intersection of what's being eliminated? And then will it be negative? Yes. So then it'll be -1 basically, and then to the third, right? It'll be negative. So we could have not written that in. I'm just going to do it for the first time at least for the video. Okay, let's go on. We're doing first row, so now we'll go to, we're going to eliminate our first row, third column now. So our minor, so plus our minor of 0, 2, negative 2, 5, times by our constant, which would be negative 1. Then times by negative 1, raised to the, isn't it even? Positive. So you can even write even, or it would be 4. Because 1 plus 3 is 4. And that's all. Right now. Now we got to calculate it. So that's it set up. Does that make sense? So it's just the minor times the cofactor, minor times the cofactor, minor times the cofactor of one row. Okay, let's do some math here. So we're going to have 12. So I'm going to do this portion right here. So we have 12 minus 20. Isn't that how you find the determinant? Then we're timesing that to 2. So wouldn't that be negative 8 times 2? Negative 16. Now I've taken care of that. Okay, let's go to this portion. So we're going to be adding that to 0 times 6, 0, parentheses, and then minus negative 8. Then we're going to be timesing that to times by negative 3. So won't that be 8 times negative 3? So wouldn't that be negative, no wait, that's positive 8 times negative 3, so isn't that negative 24? Now I've taken care of that. Now doing this one, so then we would have 0 times 5, 0, and then 2 times negative 2, so minus negative 4. You got to be really careful. You mess up on a negative, and then once again, it's all downhill from there. And then we have a negative 1 times negative 1 to the 4th. Isn't negative 1 to the 4th positive? A positive 1 times by negative 1 is negative 1. So times negative 1. So isn't that 4 times negative 1? Which is negative 4. So if you calculate that, now we'll actually add those up. Negative 16 minus 24 minus 4, isn't it negative 44, I believe? So that's your determinant, negative 44. So the determinant wasn't 0, correct? So there is an inverse of this matrix. All right, it's just that same idea over and over again, basically. Let's do another one. It gets easier as we see it over and over again. So another one. Okay. So once again, if a matrix has a determinant that is 0, then it will have no inverse. So let's look at this one, for example. Here's a bigger one. It's a square matrix though, notice. It's a 1, 2, 3, 4 by 4. So we can find the determinant, can't we? Oh, wait a minute. Okay, not that I'm going to go back and necessarily do it, but look, also in our instructions here, doesn't it say also find the determinant by expanding the second row? So instead of doing the first row, we could have highlighted the second row and done it. Does that make sense? The answer will come out to be the same though, so I'm not going to redo it. We'll just do it in this next example. A different row. So for example, looking at this one, you guys, what you're going to want to do is think smartly about this. Now, no matter which row or column you pick to be your main one, it's not, your determinant will always calculate to be the same. So you're going to want to pick the best one, meaning that's going to be the easiest to calculate. So you're going to look for what has the most zeros, because isn't 0 times something 0? So wouldn't you rather be timesing by 0 because there's less math involved? So I'm going to choose on this one for the determinant to expand by this row. I'm choosing that one, so that I have a lot of zeros. Does that make sense, everybody? Okay, so here we go. So we would start with, starting here, we have our second row, and then we would go through and eliminate column by column. So let's do our first column here. If I eliminate this, what would be the minor? Two, 0, 4, wouldn't it be? 6, 2, 6. So 6. And then 4, 0, 9. And then we're going to be timesing that by 0. You guys see how now I don't need to continue? Because we're going to times by 0, and it's going to go away. So I'm like, okay, let's go to second row, second column. Isn't our cofactor going to be 0? Same here? Okay, so now with that being the case, everybody, with that being the case, all of those are zeros. So what's the only one that really matters? The 3, right? So right here. So let's eliminate this one here. So you're going to have to picture this without the lines drawn through it. So I'll go back to highlight. We're eliminating this and this. So now we're going to write in our determinant. So that'll be 1, 2, 0. 1, 2, 0. Then we have a 5, a 6, a 2. Then a 2, a 4, a 0. Then we're going to times that by 3 times by -1 to the what power? Well, this is the second row, 1, 2, 3, fourth column. 2 plus 4 is 6. So we're looking at this. Okay, I'm going to give myself some room. Timesing by 3, because -1 to the 6 is 1. So I could do this a couple different ways. I could at this point distribute 3 in, couldn't I? Timesing a matrix by a constant, you just multiply to each element. Or I could just leave it on the outside. Which one do you want to do? You want to multiply it in? So let's rewrite what we're looking at then. If we multiply it in, we'll have a 3, then a 6, then a 0, won't we? 15, 18, 6. Then we'll have a 6 and 8. No, I keep doing that. It's not 8, it's 12, isn't it? 4 times 3? 12. 12, and then we'll have a 0. So how do we find it? So it's like finding the determinant now at this point. How do we find the determinant at this point? We have to do what we just did a second ago. So now which row are you going to choose? Or column? The ones with the zeros, aren't you? So I'm going to choose to expand around this right here. Does everybody see a column? Because then what's the only one that's going to matter? The 6, right? Because the other two will be timesing by 0. Do you guys kind of see it? So I'm going to highlight and eliminate those. So we're almost there, guys. So now we would say, okay, so our answer is 3, 6, 3, 6, 6, 12, times by 6 times by -1 to the second row, third column. So wouldn't that be 5? 2 plus 3. So aren't we timesing? So now let's do the math here. 3 times 12 is 36, isn't it? Minus 6 times 6, which is 36. And then we're going to be timesing that by 6. Oh, -6. Good catch, Axel. Because a negative to an odd is negative. So isn't that 0 times -6? Which is 0. We just found the determinant of that big, huge, nasty thing up there, the big, huge one, to be 0. So it's not that it doesn't work, it just means that we can't find the inverse. Woo! Yes. Back down here. Like, why did we only do this one? Oh, good question. So, because if we went and eliminated this first row here, like we would normally, we'll have 0. Do you see how 0 would be our cofactor? So that would just delete it. Good question, though. So that's why whenever we see zeros, we kind of want to choose that one to go off of so that it's quick. Because if we wouldn't have chose that, that would have been fine. It would have still calculated to be 0. It just would have taken a lot more time. Okay, guys, sorry. I know it's just kind of weird, and it's a lot of information. So stick with me, though. So, okay, here's a fun fact for you guys. If you have a matrix and you want to perform row operations, that's fine. you can do that, and it will not change the determinant as long as you stick to the available row operations, which we know is timesing and adding row to row, switching up rows. So a lot of times, guys, when you're given a big one, what I would do is say if there's no zeros, see if there's a place you could make a 0 or 2 doing row operations so that your determinant's going to be a lot quicker to calculate. Because you can do row operations. So let's look at this one, for example. It says find the determinant and use that to determine if the matrix has an inverse. So we know if the determinant 0, we'd say no. If it isn't, we'll say yes. So let's look at this matrix here. Notice there are no zeros, which is not favorable, especially in such a big thing. So what I'm going to do is say, can I do any row operations to create some zeros? So I'm seeing here an 8 and a 24, and then I'm seeing a 2 and a 6 and stuff. So if I take 8 and 24, is there a way I could make those 0 if I added those? Yes, row 1 times by, yeah, so let's try and do that. Let's say, okay, do row 1 times by -3, add it to row 3, equaling new row 1. Sorry, equaling new row 3. Yeah, and then you're going to add it to row 3, making a new row 3. Okay, so let's go ahead and say, well, what's not changing? Once again, what's not changing? 8, 2, -1, -4, 3, 5, -3, 11, 2, 2, 7, -1. The only thing that's changing is row 3. So let's go to row 1. We're going to times this by -3. -3 times 8, -24 plus 24 is 0. -3 times 2 is -6. -6 plus 6 is 0. Do you guys see how this is coming out nicely? -3 times -1 is 3. 3 plus 1 is 4. -3 times -4 is 12. 12 plus -12 is 0. So now it's going to be a really easy one to do for the most part compared to what it would have been. So now you say, okay, to find the determinant, what I'm going to do is pick the row or column with all the zeros, or as many zeros as possible. So now you know the only one that really matters is this 4, because that cofactor is, all the other cofactors would be 0, canceling out the determinant part. So now we have our one thing we've got to calculate here. So with that eliminated, the highlighted region eliminated, I'm going to do straight lines. I have an 8, a 2, a -4, 3, 5, 11, 2, 2, -1, and then we're going to take and times that by, isn't the intersection 4, everybody? Times by 4, times by -1, raised to the 1, 2, third row, third column. 3 plus 3 is 6. So won't that just be +1? Now I'm going to, okay, so from here, last time we distributed 4 in, let's just leave 4 on the outside. And just remember to times by 4. So I'm going to ignore 4 for a second. Now let's look here. I don't have any zeros. I'm going to do a row operation thing again so that I can have some zeros, so we're quicker. So I'm going to take and times this by -4. So I'm going to take row 3 times by -4, add to row 1, equaling new row 1. So then that would be, 3, 5, 11 didn't change, 2, 2, -1 didn't change. So we're going to take row 3, times it by -4. -4 times 2 is -8. -8 plus 8 is 0. -4 times 2 is -8. -8 plus 2 is -6. -4 times -1 is 4. 4 plus -4 is 0. So now I can just go ahead and use that row. So you guys see what it's like finding a determinant within a determinant within a, so right here you'd say I'm going to highlight this row. The only one that matters is this column, because the other cofactors would be 0, canceling out those determinants. So now you'd say, okay, so I have to do determinant 3, 11 to -1. We're going to times that by -6, times by -1 to the row 1, column 2 to the third. So look, we have a -1 times -6. Won't we have that be 6? 6 from this. And then we're going to be timesing that to parentheses. How do we find the determinant of a 2 by 2? 3 times -1 is -3, isn't it? Remember, you do this times this. Minus this times this. So minus 22. So that's -25 times 6. Grab a calculator for me, someone. Negative 25 times 6. Yep, negative 150. And then, what do we need to times it to after that? 4. So that'd be negative 600, I believe. So our determinant is negative 600. So you just can't forget, if you leave the 4 out, to then make sure you go and multiply it in your 4 as well. So is there an inverse? Yes, because the determinant did not equal 0. So basically what we just saw was if you perform row operations, it won't change your determinant. Ay, ay, ay. This lesson's kind of long. No. Okay, so this is the last thing here for the most part. Holy cow, it's like hot in here all of a sudden. Or I'm just like nervous, but I'm sweating. Okay, need some air. I need a fan right there. I'm really dying. Okay, so this is what's called Cramers Rule. So Cramers Rule for systems with 2 variables. So we've seen a couple different ways to solve this, right? Last time we learned how to solve by using matrix inverses. We've also done solving equations by reduced row echelon form and row echelon form. We're learning a third way now. It's called Cramers Rule for solving systems in 2 variables. So we're only going to be using this for right now. Well, this formula is for 2 variables, but you can use it for any number of variables, x, y, z. Like this only has solve for x, y, solve for x, y. So what you'll do, guys, is you will, here's the formula. I'm going to explain it because it kind of doesn't make sense right now. So what it says is you could literally solve for x by putting in your determinant of, so notice we have the determinant of our matrix here. So if I was to put this in matrix form, everybody, this would be matrix A, B, C, D, right? On the left-hand side. So if I said to you find that determinant, it would look like this, the straight lines. So what we do is we basically put our determinant on bottom, the determinant of the original on bottom. Now what's on top is the determinant of replacing the equal sign, sorry, how do I say this? The equal matrix, so our equal matrix is RS. What you're going to do is you're going to replace the variable you're solving for column. So notice, instead of AC, since that's the column for X, I've replaced it, I've taken RS and put it there instead. Just replacing it with the equal sign. Then we'll find the determinant. So it's basically taking R and S, putting it here, because that's replacing X, and then doing the determinant of that. So then with Y, you'll do the determinant on bottom, same thing as over here, the determinant of the original, and then once again right here, you're going to replace the Y with what's equal. So we'll still have AC, but instead of BD, we're going to replace it with our RS. So kind of a memorization thing. Now this will work as long as our original determinant does not equal 0, because we can't divide by 0. So this is how they write the formula. They say the determinant with X, that means determinant replacing column X, divided by the original determinant. So Y will be the determinant replacing column Y, divided by the original determinant. So I feel like this way is actually one of the quickest ways we've learned to solve, you'll see. Especially if it's just a 2 by 2. Well, yeah, I don't know. They're all good and bad for different reasons. Okay, so let's practice that. Okay, so we have right now this matrix. 2, 6, 1, 8. And we also have the equal sign, -1 and 2. There's our other determinant. Does everyone agree? So let's find the determinant of the original. That's the original. Let's find the determinant. 2, 6, 1, 8. 2 times 8 is 16 minus 6 times 1. So don't we get 10? So original D is 10. So I'm going to write that. Our determinant is 10. So now if we want to find D of X, determinant of X, what you'll do is you will put in your straight lines. You're going to replace your x's, which is this, with your equal sign. So replace 2 and 1 with this. So that would be negative 1, 2, 6, 8. So now let's find the determinant replacing x. So that would be negative 8 minus 12, which is negative 20, isn't it? So now look what we can find. We can find what x is. Because the formula says x will be determinant replacing x divided by our determinant. So that would be negative 20 divided by 10. So x equals negative 2. So that's pretty quick. So now we've got to do dy. That means determinant replacing the y row, column, column, column. Right here's my y column. Replace it with this. So then we would have 2 and 1, replacing our y with these. So negative 1 and 2, finding that determinant. So that would be 4 minus negative 1, which is 5, isn't it? So now to find y is determinant replace y over the original determinant. So that would be 5 divided by 10, which is 1/2. So x is negative 2 and y is equal to 1/2. And we just solved using determinants. It's called Cramers Rule. A mathematician named Cramer figured this out. So, last name Cramer. It's hard where this is the early morning takes a sec. Sorry, I'm thinking about other things right now with this next problem. The early morning is hard because we only have 15 minutes left and we still have a couple examples. So we've got to, but I feel like we got to keep going because I'm not going to be here tomorrow. Everybody don't forget that. Don't come tomorrow. I'm going to be out of town. Okay, so let's do this. So if it says to use Cramer's rule, don't we need the original determinant? So we would go straight line, 2, negative 3, 4, 1, 0, 6, 3, negative 2, and then 0, correct? So let's find the original determinant real quick. So I'm going to pick a row and column that has a 0 in it. So isn't it 50-50 if I pick this or this? So let's just go with this. Okay, let's go with that. So then what's going to matter? Is this one going to matter? No, because 0 will be my constant. So this one matters though. So let's eliminate this one right here. So I would have determinant negative 3, 4, negative 2, 0. Then we'll be timesing that by our constant of 1 times by negative 1 raised to the 2, 1, so to the third. 2 plus 1 is 3. Then we'll be adding that to, now we're sticking with, we can't do pink, let's do green. Now we're sticking with this row, but now we're going to eliminate this column, aren't we? Ignore yellow because I don't want to have to erase. So we don't need to do the 0 one because we know that our constant will be 0. So then we have plus, and now we have determinant 2, negative 3, 3, negative 2, times by 6, times by negative 1 to the second row, third column, to the fifth. So let's calculate that. Negative 3 times 0 is 0, minus negative 8. Then we're timesing that by negative 1. So won't that be 8 times negative 1? Negative 8 for that portion. Does everyone see how I'm getting that? Then we're going to be adding that to negative 4 minus negative 9 times by negative 6. So that'll be 5 times, isn't this 5? 5 times negative 6, negative 30. So our determinant is negative 38. The original D is negative 38. So from here, I need more room to write. I might have to lift the erase because I need to be able to see this stuff. Okay, so I've written that down. Let's get a bigger eraser going. Okay, so now that I've written that down, I have room to write. Now let's find d of x, meaning find the determinant when you replace column x. So what would that look like? So if I'm replacing column x, that'd be gone, right? Then that would be 1, 0, 5, wouldn't it be? Replacing our equal sign with that. Then we'll have a negative 3, 4, 0, 6, negative 2, 0. So finding this one, this is just a reminder, this is determinant replacing x. So I'm going to once again choose all the zeros. So the only one that matters is this column, because the other two constants would have been 0. So we'll have 6 times by the determinant, what did I forget? 6 times negative 1 to the 2, 3. So that'd be 5. So then we would have 1, negative 3, 5, negative 2. So then we have negative 2 minus negative 15. 15 minus 2. 13 times by negative 6. What is that? Negative 78? So now we can solve for x, because x is equal to dx over d. So that would be negative 78 divided by negative 38. 2.05? Okay. The back of the book's going to do fractions, just so you know. You'd have to do it by hand. You'd have to say, what do they both divide by? Does that make sense? Okay. Then from there, do you want me to keep going, or do you guys get the picture with that? Just switch it for y, do the same thing. Switch it for z, do the same thing. So it just takes a while. Okay. Oh, yay. Okay, this is the last thing. So I write this down. Here's how you find the area of a triangle. This formula. So the area of a triangle is plus or minus a half times the determinant of a1, b1, a2, b2, a3, b3, and then our z's are always 1. So basically, guys, you're going to be given a triangle and asked to find the area, meaning fill in the triangle here. So you're going to have your first point, second point, third point, and you're just going to do a determinant. So it'll be plus or minus. Now the plus or minus just means our area is always positive, so if it's negative, you're going to times by a negative to make it positive. If it's positive, keep it positive. So basically, all you have to do is remember, area is always positive, so you just make your answer positive, period, end of story. So we'll have 1/2 times the determinant of this. So notice, z is always 1, and then a1, b1, a2, b2, a3, b3. Mr. Roberts was saying that this lesson was, I don't think it's necessarily easy. I don't think I've classified it as easy. You think? Right, it is a lot to remember. Okay, so let's find this area here. So you'd say, okay, area is equal to plus and minus 1/2 times by, we're going to put in our first point, negative 1, 4, second point, 1, 2, third point, 3, 6, and then z is always 1. So to find this determinant now, it's going to take us a second once again. So let's pick, I don't know, does anyone have any ideas? Do you want to make something a 0 with a row operation, or do you want to just start calculating? Is that just extra work? Should we just start calculating? Up to you guys. I won't say anything, so I'm going to choose to just calculate. So here we go. Picture yourself eliminating column 1. So if we're eliminating column 1, we'll put a negative 1 times by negative 1 squared. Then our determinant, if we're eliminating this, will be 2, 1, 6, 1. Then we'll be adding that. Let's eliminate column 2 now. So wouldn't our constant be 4? Times by negative 1 to the 3. Then our determinant, if you're crossing that out, you'll have a 1, a 1, a 3, a 1. Then plus, then eliminating this, we'll have a 1 times by negative 1 to the 4. Then our determinant, if you're crossing this out, would be 1, 2, 3, 6. I swear that part of the board has issues. It's like always when I get to that part of the board. 1, 2, 3, 6. And you'll just start calculating. So let's look here. We have negative 1 times negative 1 squared. Negative 1 squared is positive. So we have negative 1 times by 2 minus 6. 2 minus 6. Negative 4 plus, let's go to the next one here. We have negative 4, because a negative to an odd is negative, times by 4. So we have negative 4 times by 1 minus 3. Then plus, let's go to here, 1 times negative 1 to the 4th. Negative 1 to the 4th is positive, times by 1, times by 6 minus 6. 0, isn't it? So now we get that's positive 4 plus 8, which is 12. So the area is 12. That is the last example. So just a lot of stuff to kind of remember, honestly. It comes with practice. If you need to go back and rewatch the video, I'll have it uploaded. And then do not come tomorrow, so make sure you're completely practiced and caught up on homework the next time I see you, which will be next Monday.